Okay. Uh, is my mic clear? Okay. Term 1, week 4, mechanics, week 5, sorry. Mechanics course division from 1.1 or 1.2 until 1.12. Until 1.12. Okay, but before I start, بتمنى منكم كلكم تقولوا آمين للدعاء اللي حقوله. With regards to what's happening in Palestine, Lebanon now, I mean, I've had this channel and I've posted videos for about 9 months, almost 10 months at this point, and I think it's time I should come and, at least say something. يعني I obviously didn't want to because I don't want to get like involved with politics, but now, after I see my country, after I've been seeing my country, after I see the catastrophes that are happening in my country, and the kids dying, well, sure, it really saddens me, and I think I should at least put it in a video. فاللهم اجعل لبنان وفلسطين بلادا آمنين، واحفظهم، وارحم كل شهيد مات وانتقل إلى رحمتك. اللهم انصرهم على العدو واجعلهم صبرا، فإنهم مستضعفين، وأنه لا يستطيع أحد مساعدتهم إلا أنت. أنت القوي، أنت الغني يا رب. آمين إن شاء الله. Thank you for saying آمين if you did. Anyway, that's too much yap. Let me actually start. Here we have mechanics. Of course, I solved some grids in a previous video, but they're in here. They're like 1.6. So I'm gonna just solve these quickly. Which of the following quantities are scalar? Akid velocity is not scalar, it's vector. Force is a vector. Mass is akid scalar. Displacement كمان it's a vector. So akid the scalar here will be mass. Yeah, شو step 1. A toy car initially at point A, which is 5 to the right of the origin, moves along a straight line towards the right and reaches point B, which is 12 from the origin. The toy car then turned around and moved through 1 meter. What's the total distance? Okay, so we started at 5, we moved to 12, so that's 7 meters. Then we turned around and we moved 1 meter, so that's 8 meters. Alright, so the total distance is 8 meters. What's the net displacement? Whole way the toy car it finished at 11, right? Because let's draw it like this. Here's the origin 0. نحن we're at 5, we went to 12, we turned around for 1 meter, we went to 11. Okay, so انت هلا you're at 11. What's the displacement? If you're 11 meters from the origin, يعني your displacement is 11. Displacement? Initially, the car was 5 meters from the origin and reaches a point 11 meters away from the origin. Net displacement. There's. Okay, look. Okay, listen. Usually, displacement is a change in position, right? With respect to the origin. Okay? In UARM and stuff, this would be wrong because the origin would usually be like at 0. So in here, I guess, yeah. I think they're taking 5 meters as the initial position. It makes sense, yeah. Displacement is always final minus initial. خلاص, I just do 11 minus 5. Okay, x. This is x. Delta x. But then later in UARM, it's going to be x final equals half at squared plus ut plus x naught. That's for later. That's for an hour ahead from now, or half an hour ahead. An ant moves along a stick at time t0. The ant was at position x1, which is 10 centimeters. Okay, so this was a question in the book. I remember solving this in class. Here, x1 is at time t0. So this is the initial position. If they say t0, yani that's your initial position. Moving in the positive direction to x2, 25, and then it finished at x3. Find the displacement. Some people, for some reason, they do 15, and then some people would put like 40. Okay, I don't know why. When we say displacement, you just do final minus initial, delta x. Right? What's the final position? Minus 5. What's the initial position? 10. So it's minus 15. Oh shit. Stop. They said second phase. I didn't see this. Okay. My fault. Okay, that's 2 questions in a row wrong. I got it again. Hold up. They said second phase. Second phase, we have the first phase, which is from There's the first phase is from 10 to 25, and the second phase is from 25 to -5. Okay, I didn't see this. I didn't see second phase, and they're asking what changed here. -5, -25. Okay, this is -30. المشكلة in class I answered this correct. I remember I was making fun of my friend because he got it wrong. My friend did -5, -10. Okay, and we were joking around. I was like, oh no, they have second phase. Anyway, read the question carefully, especially in the exam. Please, please. I'm telling you, he's probably gonna get a question like this. بصراحة. The box shown moves uniformly, covering a distance of 5 meters per second every 2 seconds. 5 meters every 2 seconds. What's the speed of the box? Distance, time. That's it. Speed is distance divided by time. 5 divided by 2, which is 2.5. What's the velocity? Velocity is displacement over time, right? X over t. So it's gonna be, again, 5 over 2, which is 2.5 meter per second. أكيد guys the unit, huh? A particle covers a distance of 120 meters at a speed of 15 meters per second. Then an additional 200 meters at a speed of 10 meters per second. What's the average speed of the particle? State necessary assumptions. Okay, أول شيء we have two phases of motion here. We have this one here and then this one over here. So this is phase 1, or this is phase 2. Okay, in phase 1 we want average speed, and you know that the average speed is distance divided by time. We have the total distance, which is 200 plus 120, which is 320, but we need the time. How can we find the time? Let's look at each phase of motion. Here we have the speed is 15 meters per second. We know that the speed is equal to the distance, 120, divided by the time. So I can easily find the time, and it's gonna be 96, 8 seconds. Here, 120 divided by 15, huh? That's how I got 8 seconds. Okay. Here in the phase 2, speed is 10 meters per second. So 10 equals the distance, 200, divided by the time. And you're going to get that the time is equal to 20 seconds. Okay. So your total time is 20 plus 8, it's 28 seconds. Can we find the speed? 320 divided by 28. And just put that in a calculator. 320 divided by 28. 11.4. Where am I now? Yeah, 11.4. Okay, okay, traveling along a straight line, it starts its motion at noon. Noon يعني 12 p.m. Okay, and moves at a constant speed. Okay. At 12:15, its instantaneous speed is 60. At 12:30, it changes its speed and maintains it constant for 0.75 hours, covering another 70 kilometers. Okay. State the instantaneous speed at 12:20 and 12:40. Okay, let's see. At 12:20, we know that from 12:15, we maintain this speed of 60 until 12:30. So from 12:15 until 12:30, it's 60. They want a 12:20, and that's in between 12:15 and 12:30. So at 12:20, it's 60 kilometer per hour. How about 12:40? 12:40, they gave us the distance it traveled and they gave us the time. So can't we just find the speed? Yes, we can. Distance divided by time. So 70 divided by 0.75. It's times 280 divided by t. I don't know. It's a decimal, I think. 70 divided by 0.75. 93.3 kilometers per hour. Let me make sure of this answer. Yeah. Oh, they kept it as two significant figures. For part B, when they're asking what's the total distance, we need to find the distance in the first phase from the start until 12:30, and then from 12:30 until the end. Okay, so let's write everything down again. Okay, here at 12, it starts at noon and moves at a constant speed. Okay, it's moving at a constant speed, and then they checked at 12:15 what is that speed, and it's 60. And then they maintained that speed until 12:30. So from 12 until 12:30, it was 60 kilometers per hour. From 12:30, it maintained this constant speed for 0.75 hours. In other terms, 0.75 hours is 45 minutes. Okay, so 45 minutes will be 1:15 p.m. What was that speed? We found it was 93 kilometer per hour. Can we find the distance? Here, we know that the distance is equal to x equals velocity times time, right? Velocity equals x divided by t, or whatever speed you want. Speed equals distance divided by time. So distance equals speed times time. Okay, distance equals speed times time. So in this case, the distance is the speed, 60, times the time. How much hours here? It was 30 minutes, which is 0.5 hours. Alright, because 30, to convert from minutes to hours, you divide by 60. 30 divided by 60 is 0.5. So you get 30 kilometers. Then here, we want, this is 115, no? My handwriting is but this is 115. Okay. Then here, again, to find the distance, it's the speed, 93, times the time. From 12:30 to 1:15, they said it was 0.75 hours, right? Okay. And here you get, I don't know how much, 93 times 0.75. 69.75. So you could just say 70. Around 70. Plus 30. So it's around 100 kilometers. My handwriting today is so bad. You could say about 100. For part C, what is the average speed of the boat? Average speed is the total distance divided by the total time, right? نحنا, what's the total distance traveled? We said in part B, it's 100 kilometers per hour, right? So هون 100 kilometers. So the distance is 100. How much was the time? The time was, we started at 0.5 hours, right? It was first, remember, from 12 until 12:30, 0.5 hours, plus here 0.75 hours, which is 1.25 hours. Okay, so 1.25, put this in a calculator. 0.5 as the 100 divided by 1.25, you get 80. So average speed was 80. Question 7. Okay, the position time graphs of the two toy cars are shown below. Calculate the average velocity of each car. Average velocity is equal to the slope of the secant. So they want 2 points. You know, average velocity is x final minus x initial divided by time. Now we can take any 2 points. The easiest points would be probably here. 8 seconds, 4 meters. And here, 4 seconds, 6 meters. Final minus initial, 6 minus 4. Or sorry, 4 minus 6. 4 minus 6. It doesn't matter the order, by the way. Over 8 minus 4. You get negative 0.5 meter per second for car A. This is V of A. Hala, V of B. It's gonna be final minus initial. 8 seconds, we can take 2 points. 8 seconds, negative 2 meters. وكمان we can take 6 seconds, negative 4 meters. Velocity of car B, we do final minus initial. Minus 2 minus minus 4. Minus minus 4. Please, common mistake is that people will not put the minus. They put minus and they just put 4. Minus 2 minus final minus initial. So minus 2 minus minus 4. Okay, over the time 8 minus 6. You're gonna get 2 over 2, which is 1 meter per second. Yeah, let's check this answer. Should be negative 0.5 and 1. Yes. Assume the cars continue moving uniformly at their speed. Okay. Explain how to determine if the cars ever meet. I got a different way than how they solved in the course revision. but I think honestly their way is more straightforward. My one's a bit more math. So we have these two cars, B and A, right? So what they said is to see if they meet, just extend the lines. Okay, if you extend these lines, I'll take this to the open board because I want it to be a bit more of an exact answer. Uh, so over here, let's extend this line. It's not so bad. Okay, heck. Okay, oh heck. So obviously they do meet, right? But at what time? Like, explain how to determine if the cars ever meet. Just extend both lines and see. I'm not gonna write it all and see if they intersect. Calculate the time. Just it's over here at 12 seconds. Determine which car has covered the greater distance. Akid is gonna be car B because car B was 1 meter per second. Heidi Hon 0.5 meter per second. Okay, okay, the one that has a greater speed would have covered a greater speed. Justify, like what I said, if since car B had a greater speed, that means it will cover more distance in the same time. If you want to do my way, look, you can see the solution. Just extend the lines to see if the two cars intersect, and then they extended the graph. I mean, also our graph here is only until 11. I don't know how they expect us to use this method. But they're saying, okay, whatever, they intersect at t equals 12, and then car B, okay. If you want my way, when they intersect, that means x of A equals x of B. And we know that each x, we know V equals x divided by t, right? So x equals Vt plus x node, akid. I'm gonna start writing x node because we need it for later. We know that each x is equal to velocity times time, right? Plus x. So the x of A, which is Vt plus x node. What's the velocity of A? We said it was negative 0.5. So negative 0.5. X node is 0 in this case because it doesn't matter. Oh, it doesn't matter. Wait, let me see. Yes, yes, it doesn't matter. Because x initial, here it's starting at 8 meters. Okay? So our x for car A is the velocity of A minus 0.5 times t. We don't know t. Uh, x node is 8. We know it's equal to x of B. What's the velocity of B? We said it's 1 meter per second. Remember? 1 t plus x node, which was negative 10, so minus 10. Now this is a simple mathematical equation. You get minus 0.5 t plus 8 equals t minus 10. Solve this, you get t equals 12 seconds. So you say they meet at 12 seconds. Okay, you could say this is more math. But whatever you want. I don't think they'll get a question like this. Okay, I'm gonna skip this. It's pretty straightforward. Actually, you know what? I'll do it fast. They're pretty easy questions. What's the velocity? Because I solved this before in term 1, week 4 mechanics. What is the velocity of cyclist at t equal 4 seconds? Akid, they want at a certain instance, so they want instantaneous velocity, right? And when you want anything instantaneous, it's the slope of the tangent. Okay, slope of the tangent. This is a straight line. You know, the tangent to a straight line is the line itself. Okay, so in this case, we just take the slope of this line. We can take these 2 points, 6, comma 8, 6 seconds, 8 meters. وكمان 0 second, 24 meter. Final minus initial, 8 minus 24 over 6, which is minus 18 over 6, 16 over 6, sorry. Minus 16 over 6 meter per second. However much that is, should be minus 2 points. Is it minus 2.7? Divide by 2 up and down, you get minus 8 over 3. That's 2.67. Yeah, 2.7. Question 9. The diagram below shows the change in position of a swimmer in a freestyle swimming competition as a function of time. So x with relation to t, xt. She covers the length of a pool within 34 seconds. She swims back to her starting point in 26 seconds. So, she 34 seconds, she covered the length, she stopped for like a quick sec, and then she returned. At which point is the swimmer at rest? Excuse me. At which point is the swimmer at rest? أكيد over here at point D. So I even predicted the question. Point D, right? Because here, surely tangent. True. What do they say tangent? Because the tangent at this point is parallel to the x-axis. Okay, yeah. Okay. I think what they're trying to say is if they're saying at rest, yani v equals 0. And you know, when v equals 0, that means it's tangent. The tangent is horizontal. Because you know, the slope of a horizontal line is 0, guys. Remember in math, these horizontal lines, there's no change. So just the slope of it is 0. That's actually why whenever you see a horizontal x line, you know that v equals 0. Because there's no change in x. Okay? Anyway, so they said, okay, D because the tangent is horizontal, or you could say parallel to the x-axis or t-axis. Okay, to the t-axis. This isn't x-axis, t-axis. Anyway, in which interval is the velocity constant and negative? Okay, constant yani straight line, oblique line, whatever. Oblique line, straight line mean the same thing. So akid, it's not here because it's curved. This is curved as well. Okay, over here, we also want it to be negative, so sloping downwards. So it's not here, and that means it's in this time interval over here. This is at, oh my god, I'm gonna have to zoom in. See, the tangent. Okay, how can I say this? Well, they won't really ask this, but if you do derive, look, you know that if you derive x, you get velocity. If you derive velocity, you get acceleration. If you derive a straight line, you get a horizontal line. And if you get a horizontal line, that means it's not changing. That means something is constant. And if you derive the straight line, you're going to get the AT graph. Heck, it's just a straight line. Okay? I don't know how I can explain this better. Just look at the solution, to be honest. 15. Does a positive acceleration always mean that a body is accelerating? Explain. Akid here, no. If you, it only means that the body is accelerating if we're moving in the positive sense, right? But now we also said that acceleration is positive. It's positive whenever you're sloping upwards. We said that command you can be sloping upwards in the negative sense. Here, we said it's slowing down, right? We said it's slowing down. So akid no. The explanation to this is it means that the body is accelerating only when it is in the positive sense. However, if it's in the negative sense, velocity, however, if you're in the negative sense, meaning yani velocity is negative, a positive acceleration means the velocity is increasing. What do you mean it's increasing? You're going from negative, I don't know, 10, and you finish like here at negative 2. Didn't you increase, yani didn't your velocity increase? Isn't negative 10, as in, isn't negative 2 bigger than negative 10? Yes, so velocity is increasing, but the magnitude of the velocity is decreasing. Remember, magnitude means yani the positive value of it. So consequently, we say it's slowing down. Okay, that sometimes it might mean it's slowing down. Consider this: the instantaneous acceleration at t equals 5 is acceleration 5, and its acceleration at t equals 7 is a7. Compare the magnitudes of these accelerations. Okay, at t equals 5, the instantaneous acceleration is equal to the slope of the tangent, and this is a straight line. So the tangent of a straight line is a straight line itself. Okay, here compare the magnitudes of these accelerations. Okay, the magnitude t equals t equals 7 at a7 commences a straight line. Okay, we want to see which one is bigger, right? Okay, the one that's steeper is going to be the one that has a greater acceleration. Because they're talking about magnitude. They don't care about the sign. We only care about the magnitude. Okay, here, look, it's not steep, but this one here is going down. So I want to see how they said this in the solution. 16. The slope of the line including t equals 5 is smaller than the slope of the line including t equals 7. Since it is less steeper, a5 is less than a7. Okay, that makes sense. At 1 p.m., a car is spotted traveling at a constant velocity of 25 towards a street sign 2000 meters away. Determine the equation of motion. Equations of motion and the QRM and the QARM. احفظون, like I told you in the quiz video, memorize them like it's your name. Memorize. Okay? Constant velocity. شو يعني constant velocity؟ يعني أكيد UARM. There's only one formula we know for UARM which x equal vt plus x node. يعني ال x هي velocity 25 times the time, I don't know, t. It's always in terms of time, plus x node. نحنا we're 2000 meters away from the sign. If we're away from something, that means we're negative 2000. We're behind it, right? Like let's say the sign is over here. نحنا we're 2000 meters away from it. We're taking the origin here as the sign. If this ever comes in the written, say choose the street as the frame of reference, and the street sign is the origin. We say choose the street sign as the origin, and the positive direction as the direction in which the car is moving. Origin of time is t equals 0 and it's 1 p.m. La 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 la, which means the car is moving in the positive direction. Given that the car is moving with constant velocity and x node is minus 2000 since we're 2000 meters behind, okay, the equation of motion is 25t minus 2000. So to summarize what they said, they said choose the origin of position as the street sign and the direction of motion of the car as the positive sense. So this is the positive sense. Car here, it's over here, right? It's 2000 meters behind, right, to the left. So this is where 0 is. They chose this as the origin. So this is at أكيد minus 2000. That's just to help you understand what I did here. What is the total displacement here in 20 seconds? It's a VT graph. Displacement in a VT graph is just the area under the graph. This is a trapezoid. So, area of a trapezoid is base 1 plus base 2 over 2 times the height. Base 1 is 20. Base 2 is 10 over 2 times the height, which is 6. You get 90. You should get 90. Yeah. Okay, a toy car is initially moving in the positive هلا UARM يا حبيبي. Okay, قربنا نخلص. A toy car is initially moving in the positive direction at 0.5 meters per second. So they gave us initial velocity. Remember, how do we work? Like I told you, this is how I work. I list everything they give me on the right. So u equals 0.5 meter per second. At t equals 0, the car accelerates at 0.2 meters per second for 6 seconds. They gave me acceleration is 0.2 meter per second square. Okay, and the time they gave me is 6.0 seconds. What is the displacement? بدهم x. What equation can I use to find x given a, u, and t? I think they're still, oh no, they're not. Okay, هكتبهم fast. URM x equals vt plus x node. UARM v equals at plus u. These two are the most basic ones. Everybody should have them memorized. They come from velocity is equal to delta x over t. So actually delta x is velocity times time. In other words, a v equals x final minus x initial divided by t, because delta x is final minus initial. So أكيد x final you're gonna cross multiply x final minus x initial equals vt, right? Velocity times time. Take x initial there. You get x final equals vt plus x initial or x node, whatever you call it. Okay, this is how this came from. Over here, acceleration equals delta v divided by t. So it's equal to velocity final minus velocity initial divided by t. Cross multiply, you get velocity final minus velocity initial. Okay, v initial. Okay, equals acceleration times time. Take velocity initial there. Velocity initial, in other words, we call it u. Okay, initial velocity we call it u. So velocity final equals at plus u. These are how these two came from. These ones, everybody should have them memorized. Second one, x equals half at squared plus ut plus x node. Third one, x equals u plus v over 2 times t. Fourth one, x equals half at شو half at squared, sorry, no, v squared minus u squared equals 2a delta x. Okay, delta x, or you could just say x, whatever. Okay, here what are we gonna use? أكيد, which one has x, a, t, and u? We're gonna use x equals half at squared plus ut plus x 0, which we get half at squared. So half, just substitute. So like these questions, wallah, they're so easy, bro. All you have to do is just substitute the formula. But you just need to know the only hard part is seeing what is my formula that I'm gonna use. والله ما فيش أسهل من هيك. Okay, يعني in mechanics. صراحة for me this is the easiest concept we have. Wallah, I'd rather do this than vectors or whatever. Okay, plus u, which is 0.5 times 6 plus x node. It's not given, so it's just 0. Put this in your calculator. مانيش حاطة. Where am I? 6.6 meters. Okay. The position of a particle moving along the x-axis is x equals 3t minus 2t squared. Oh, I like this question. Okay. Determine the characteristics of motion of this particle. Okay. When you say characteristics of motion, and also is URM or UARM. Okay. Let's see. Whenever you see squared time, immediately you know UARM. Okay. So here it's going to be UARM because you have time squared. Okay, I think the motion of the particle is rectilinear and it's the form of x equals half at squared. Yeah. So if you compare this to, listen, the first thing I like to do, I hate it when the leading term is not the highest power. So and I like taking this to t squared here, minus 2t squared plus 3t. If you compare this, we can compare it to our formula half acceleration times time squared plus ut, right? Plus أكيد x naught, whatever. But it's 0 in this case. Okay, see, by comparison, we found out that it's UARM. So here, the motion of the particle is rectilinear, and UARM stands for uniformly accelerated rectilinear motion. And its equation is the form x equals half at squared plus ut plus x naught. Okay, and then now, okay, they're asking us to find أكيد they want you to find what are the values of a, u, and x naught. We know that negative 2 is equal to half of a, right? Negative 2 equals 1 over 2 a. So you're going to get a equals negative 4 meter per second squared. Why? Because just look, by comparison, what's the coefficient of t squared? Negative 2. What's the coefficient of t squared here? Half a. So you just compare them. Here, u directly equal to 3. Well, x node is equal to 0. And this wasn't written here. X node equals, there's nothing here, so 0. That's it. Look, v node equals 3, and u equals 3, half a equals negative 2, so you get a equals negative 4, x node equals 0. Okay. Part B. Determine the velocity of the particle at t equals 3 seconds. Now we have, let's erase this. We have that from part A, we have a equals negative 4 meter per second squared, u equals 3 meter per second, x0 is 0. Okay, can we find the velocity at t equals 3 seconds? Can we find velocity if you have the acceleration and the time and أكيد u? أكيد, easiest formula to use to find velocity is at plus u. So we use acceleration negative 4 times the time 3 plus u, which is 3. You get negative 9 meter per second. Determine the average velocity between t equals 2 seconds and t equals 6 seconds. Anytime you see average velocity, it's x final minus x initial divided by that time. Okay, so we need to find the x at t equals 2 seconds, x at t equals 6 seconds, okay, and divide by time. We know that x is equal to 3t minus 2t squared, right? Or minus 2t squared plus 3t, whatever. It's the same order. It doesn't, the order doesn't matter. So let's see. X at 2 seconds is equal to 3 times 2 minus 2 times 2 squared. 6 minus 8, negative 2. So x at 2 is negative 2. How about x at 6 seconds? It's 3 times 6 minus 2 times 6 squared. 18 minus 72, which is 54, negative 54. Let's see. So our final is at negative 54. Our initial is at negative 2 over the time, which is 6 minus 2, which is 4. So you get negative 52 over 4, which is negative, you get negative 13 meter per second. صح؟ شو dx over dt? They use derivative. Okay, wait. I'll get to the derivative in a sec. C is negative 13 meter per second. Okay. I like this way. I like this way a lot. Okay. But what did they find here in the? I don't know, what am I saying? At t equals 3 seconds, wasn't it negative 9? Yeah, negative 9. Okay, and then this is the solution to part C. Okay, look, for part B, they use derivative. Okay, I like this a lot, by the way. You know how we have x? If you derive x, you get the velocity. If you get velocity, you can get a. Okay, in math, remember, we didn't use in IG math last year, we didn't use formulas. We used to derive. If they'd give us x, we would derive x to get the velocity. Instantaneous velocity, right? When they say at t equals 3 seconds, and we want instantaneous velocity. So we need the equation for v. Can we find the equation for v if we have the equation for x? Yes, you can. If you just derive the equation for x, you get the equation for v. Derive dx over dt of 3t minus 2t squared. You get derivative of 3t is 3 minus 2 times 2 is minus 4t. So v equals 3 minus 4t, and then you can just plug in t equals 3 seconds, so 3 minus 4 times 3, which is negative 9 meter per second. Same answer, huh? Okay, so see how, and I just derived, I found out the equation for velocity in UARM. This is actually how they figured out the equation for UARM. It wasn't just a guy who was bored and just found out, oh, this is how you do it. No, that's not how formulas come. People actually prove them. Okay. 21. A car is moving at a speed of 30 meters per second. Where, oh, this one. Okay. I'm gonna solve this myself. Wait, okay, hold up. For this one in the solution, they yap a lot, okay? And I'm gonna give you the way I solved it. It's the same as the solution, but you know, they're doing too much, you know what I mean? So look, here we have the car which is moving at, I just wrote them up. It's moving at speed of 30 meters per second, where the speed limit is 80. Okay, the point of the question isn't to see if, oh, he's driving above the speed limit. We know he's driving above the speed limit. You want to see it yourself, 80 divided, convert to meter per second, you divide by 3.6. You're going to see he was driving above the speed limit. That's why the police officer on his motorcycle, he spotted the speedy car and starts chasing it 2 seconds after the car has passed. Okay, the car and the motorcycle, they're moving along the same path, whatever. We want to find the distance covered by the car before it is caught by the police officer, given that the motorcycle accelerated from rest at 6 meters per second squared. Take the origin of time and frame of reference as the point at which the speeding car passes the police officer. Let's see. We want to find the distance. Okay, we know that the distance obviously traveled by the police car is equal to the one traveled by the distance traveled by the car is equal to the one traveled by the motorcycle, the police motorcycle. Why? Because he caught him, right? He ended up catching him, so they finished at the same position. Okay, let's investigate the position of the car. Since the position of the car, he's traveling at a constant speed, which is URM, right? If it's at a constant speed, and URM. So his x is equal to the velocity of the car times the time plus x naught. Let's start substituting. The velocity of the car is 30 t plus x naught. Let's see. What's our initial x? See here, the car, he passed the police officer, and he was 2 seconds ahead of the motorcycle. Okay, for those who watch Formula One, I'm sure you know what I mean by 2 seconds ahead. So here's what happened: the car, there is the motorcycle here, whatever, I don't know. What I imagine is the motorcycle. Okay, and the car passed him. Okay, the motorcycle waited until the car was over here. He waited 2 seconds. Okay, so we need to find how much distance. Well, it's 60, but how much distance was traveled in those 2 seconds? Can we find out? We know that x is equal to the velocity times the time. So the velocity, we know he's traveling at 30 meters per second, right? From the question. In those 2 seconds, he traveled 60 meters. So that means the car, its initial position, it was always 60 meters ahead of the police motorcycle. ماشي. So this is the x of the car. هلا the x of the motorcycle. The x of the motorcycle, they gave us acceleration, okay? And we want time, with relation to time. We want acceleration and with time, in a certain time. How can you find x if you have a and t from UARM? You're going to use x equals half at squared. Okay, for the motorcycle, it's going to be half x equals half at squared. You can say plus ut plus x naught, but they're both 0 because we started from rest. They gave us u equals 0. Okay, and x naught is equal 0 because he is at the origin. Okay, he's at the origin. We took the origin as where the motorcycle is parked. So half acceleration, which is 6, times t squared. Okay, so you're going to get 30t plus 60 equals 3t squared. This is a quadratic equation. Take everything to the other side. 3t squared minus 30t minus 60 equals 0. Put this in your calculator. Equation mode 3. Okay, 3 minus 30 minus 60. Okay, so you're gonna get two answers, 11.7 seconds. And your second answer, I think it's negative 1.7 second. Okay, Akid, you're gonna write beside this rejected. Okay, rejected because it's wrong. Yani. You can't have a negative time. So we found our time. Here, are they asking to find time or x, right? So now you can just substitute this time 11.7 into any of these two equations. It would obviously be easier to use 30t plus 60. So 30 times 11.7 plus 60, and you get 411 meters. Apparently, this came in the periodic last year, and most people got it wrong. So just be careful. If it was like this, either they asked they asked it like this, or they asked it in the same way as the quiz. I forgot. But make sure you know how to solve it, because this will come. I'm pretty sure. Okay. Halla 22. 22 is very easy. They gave us that it's initially moving at 10, so u equals 10. Its acceleration is, it's decelerating, and its a is negative 2.5. Okay. What is the displacement? X, over 6 seconds. So we want x when we have a, t, and u. How will we find it? X equals a t squared plus ut plus x naught. Okay, so my x is going to be equal to half acceleration is negative 2.5 times the time squared, so 6 squared, plus the initial velocity 10 times the time 6, and they didn't give us x naught, so we just don't write x naught. Okay, so you're going to put this in your calculator. 0.5 times minus 2.5 times 6 squared is 36 plus 10 times 6, you get 15. So x is 15 meters. 15 meters. Super easy, guys. Very, very easy. These questions super easy. Just know how to apply the formula. A motorcycle accelerates from rest to 30 meters per second at a rate of 5 meters per second squared. In t seconds, calculate the distance covered by the motorcycle before it reaches the final speed and calculate the value of t. Okay, here what most people will do is they'll find the time and then they'll find the distance. And I don't want that, guys. Okay, I do not want this. أول شيء, treat it as part A, part B. Part A is to find the distance, part B is to find the time. If you have a written part A they tell you find distance, part B they find time. Do you find the time to find the distance in part A and then in part B you find the time again? No, this is wrong. So basically what they're trying to say is find the distance first without finding the time. So let's remove this. Okay, I want to find the distance. I want to find x given u is 0, v is 30, a is 5. Okay, so I want to find x without time. This is a very useful one. Okay, use the equation v squared minus u squared equals 2ax. This is a very useful equation. You can use it a lot. When you don't have time and you want to find x, you use it. V squared 30 squared minus u squared, yes, 0 squared, we don't write that, equals 2, acceleration time is 5, x. You get 900 equals 10x. You get x equals 90 meter. Okay, هلا we can erase this and we can see calculate the time. How do we calculate the time? You literally can use any equation, guys. Okay, we can use v equals acceleration times time plus u, right? We can use this is the easiest one. First formula that came in my head. 30 equals acceleration, which is 5 times t, u is 0, so plus u. You're gonna get 5t equals 30, t equals 6 seconds. Very common mistake is that students would do this step first before doing this. We want to find distance first, okay? So you're gonna get x equals 90 meters and t equals 6 seconds. What did they use? Placing delta x. They use this? Okay, no. We just use v equals 80 plus u. Okay, so yeah, they used both. Yeah, they used both. Okay. A train moving along a straight track accelerates from rest at 2 meters per second squared for 20 seconds. It then moves at a constant speed for 120 seconds. Finally, the train decelerates uniformly to a stop. Write the equation of motion of the train in each phase. We have phase 1, which is UARM, because it's accelerating, right? So equation of motion, when we say equation of motion, it's either v equals at plus u or x equals vt plus x naught. Since we have UARM, we have v equals at plus u. So in this case, in phase 1, the acceleration is 2. We always put it in terms of time. Oh. Wait, let me see the answer. They gave us time. X1. Oh, do they want X? Oh, okay, 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 okay. Mm-hmm. Okay, so what I'm seeing, oh, that's a long solution, bro. What I'm seeing here is they found the X and they found the V. Okay, so I guess, yeah, we could say 2t plus u, since it's from rest, it's plus 0. We know that t is 20, so 2 times 20. So you get v equals 40 meter per second. Okay, and then just write x equals, we also want x, half at squared. And u is 0 and x naught is 0, so we're just going to keep it as half at squared. Half acceleration is 2 times, we just keep it in terms of t squared. Okay, which is 2 cancels with 2, it's 1, so 1t squared. Okay, and in this case, it's 1 times 20 squared equals 400 meter. If you have this correct, this is bam, for phase 1, correct. Phase 2. Phase 2, it's at a constant speed for 120 seconds. So we took the speed 40 and we say it constant. You know, when you have constant speed, yani URM. And in URM, we only have one equation, it's Vt plus x naught. So for phase 2, we have x equals Vt plus x naught. Okay, what is our x node in phase 2? Let's start with what's our velocity? Our velocity is 40, right? So x equals 40 times the time. Let's keep it in terms of t plus x node. X node, what's our initial x? At phase 2, we would have traveled 400 meters, right? So plus 400. Let me just verify if this is correct. 40, where are we? Phase 2? Hold up. Yeah, I checked. This is correct, except that they replace the time with whatever time they're at minus 20. Because remember, we're starting at 20 seconds here. And we started at 20 seconds. So we want to know after those 20 seconds, right? So 40 t minus 20 plus 400. You get this. Okay. And in this case, they want, what at the end of this phase, since they said for 120 seconds, for 120 seconds, yani, was it 120 after? Let me see. Is it 120 after? Yeah. So this is for 120 extra seconds, right? So it was 20 plus 120. So right now t equals 140 seconds. Okay. So x in this case would be 40. 140 minus 20 plus 400. And what do you get? You get 5,200 meters. Okay. Yeah. 5,200 meters. Phase 3. Okay. We're decelerating uniformly to a stop in 40 seconds. Okay. أول شي بدنا نلاقيه is our x. Okay, or our v, sorry. Let's find our v. V equals, again, since UARM, it's v equals 80 plus u. How do you know it's uniformly? Because decelerates. Okay, v equals 80 plus u. The acceleration, can we find it? Yes, we know. Velocity final minus velocity initial over the time, right? We don't have our acceleration, but we know that it stopped in 40 seconds. The time is 40. The final velocity is akid 0, and the initial velocity was, how much was our velocity here? It was at 40. So you get negative 1 meter per second squared. So v equals minus 1 t plus should be 40, right? Let me see, is it minus 1 t plus 40? Okay. Hold up. بديش x, بدي v أنا. They didn't give me v? Okay. Okay, they're just giving me x. I guess, okay, yeah. You get this for v. Because our initial velocity was at 40. We were at 40. How about for x? Again, we're going to use half at squared plus ut plus x node. Half negative 1 times the time squared. Again, by the way, t here, guys, is a t minus 140. Why is it t minus 140? Because, I mean, here we reached 140 seconds, right? Hella, it's actually, wait, t minus 140. Yeah, we reached 140 seconds. So we want to just do, we want to subtract those earlier 140 seconds to determine where we are right now. Okay, so t is t minus 140. So t minus 140 plus ut, our initial velocity was 40. t minus 140 كمان. x node in this case is gonna be 5,200. Oh my god, 5,200, like I wrote here, right? We found it in phase 2. So this is the equation of motion for the third phase. If you want to simplify it a bit, let's simplify. You're gonna get negative 0.5 t. Oh, this should be squared, huh? T minus 140 squared plus 40 t minus 140 plus 5,200. Is that it? Yeah, that's pretty much it. Okay, part B. Find the position at t equals 5 seconds, 6 seconds, and 150 seconds. At t equals 5 seconds, where do we fall? We fall in phase 1, right? And we know our x in phase 1 is equal to 1t squared. So x equals 1 times 5 squared, which is 25 times squared meter. Let me just make sure if I'm doing this correctly. Yeah, but it's less than 20, 25. هلا 60 seconds, where do we fall? أكيد we fall under phase 2. This phase 1 is for time less than 20. Phase 2 is for time less than 140, صح? Hold up. Yeah, less than 140, but greater than 20, صح? In between 20 and 140. In this case, 60 is in between 20 and 140. So we're going to use our x equals 40t plus 400. So x equals 40 times 60 plus 400, which is 2,800. I think. Oh shit. Oh. We said 40t minus 20. My bad. X equals 40. We wrote it here, right? I continue to say that x equals this. Okay. 40 t minus 20. So 60 minus 20 plus 400. And then you get 2,000. How long is this recording? 52. Okay, we can get it under an hour. And then 160 seconds. Akid, this falls under here for t between 160 and 140. Or is that 100, 100, between 180, supposedly? Yeah, between 180. Because here it stopped at 140, then 140 plus 40 more seconds. Yeah, it's in between 180. Okay. Okay, so it falls under here, and we know that x in this case is equal to this. So we're going to do x equals minus 0.5. T is 160. We said t minus 140, huh? 160 minus 140 squared plus 40. 160 minus 140 plus 5,200. Whatever you get here, 5,800 meters. So honestly, I don't think they'll get this question, but do it in case, you know. Okay, هلا free fall. An object released from rest several meters above the ground moves at a constant acceleration in the absence of air resistance. What is the numerical value of the acceleration? Actually, this acceleration is known as g, and we know it equals 9.8 meter per second square, if I'm not wrong. Yeah, 9.8 meter per second square. Question 26. Describe the apparatus used. Okay, this one you memorize it. Okay, they're gonna get this probably in the computer part. What are the apparatus used? What do you need to determine g, or the acceleration of free fall? Steel ball, electromagnet. Okay, trapdoor, and electronic timer. Okay, to connect the electromagnet and the trapdoor. Sorry, no. You need the timer, which is connected to the electromagnet and trapdoor. A ruler to measure the distance between the magnet and the trapdoor. Here's what happens, huh? We know that G equals, from the quiz video, hold up, it's 2 times the height times squared. This is what G is equal to. So what they do is they take a ball, okay, they measure the distance, say like 0.5 meters, and then they connect, they put a trapdoor. As soon as the trapdoor opens, the timer starts, and it measures the time needed to fall through 0.5 meters. So you just use this formula. Okay, you're not responsible for this, but what are you responsible for? And to just memorize, you need a ball, an electromagnet that triggers the trapdoor, and then the timer that's connected, and okay, the ruler. Okay, I like question 20. This is a heavy question. Okay. A boy is standing near the edge of a roof. Using a slingshot, he shoots up a pebble from a point located 45 meters above ground level. The pebble leaves the slingshot with an initial velocity v node equal to 24 meters. U is 24. Directed vertically upward, it moves up to reach its highest point, then goes all the way down to the ground, barely missing the rooftop. The figure below illustrates the situation. Neglect friction, use G is 10. Determine the maximum height reached by the pebble and calculate the time it takes to reach that point. Now we want the maximum height, which is, let's just call it x. We have acceleration, we have u, and we know that the velocity, the final velocity when he reaches the maximum height is 0. You have acceleration, you have u, you have v, you want x. So we want to find x without having time. What do we use? We use v squared minus u squared equals 2ax. The final velocity is 0, because when it reaches the maximum height, it's 0. So 0 squared minus u squared, which is minus 24 squared, keep the minus outside, equals 2 times the acceleration, which is negative 9.8 times x. طب وليد, why is it negative? Why is it negative 9.8? قصدي negative 10. My fault. Negative 10. But that's not my point. My point is, why is it negative, not positive? Because this is the acceleration of the weight, which is pulling you down. Is the you're going up, the acceleration is opposite to your direction of motion. So أكيد it's going to be negative 10 instead of 10. Okay, it's supposed to pull you down while you're going up, so it's going to be opposing your direction of motion. Let's do this. You get minus 24 squared divided by negative 20, because 2 times negative 10, you get 28.8 meters. If you get a negative answer, you should know something is wrong. Okay, 28.8 meter. Let's see, 28.8. Okay, find the time. Okay, I won't erase. When the pebble passes by the initial position where it was shot, and determine its speed at that instant. What can you deduce? Okay, so they want to find the time it took, and how long did it take to return back to this initial position. I like this question a lot. Okay, this is very nice. I think Salaha, they maybe, if they don't get past paper, they might get this. I still haven't, right now, I'm going to record the past paper questions as soon as I finish this recording. So I still haven't taken a look at the past papers. So they may, let me eat a peach. Anyway, yeah, they might get this in the written or even computer part, because I still haven't seen any questions. Tastes good. Any questions that contain this type of free fall question. So please be prepared to solve a type of question like this. Question 27. He got this, the physics regional. He got this like in the physics periodic. He got a question from the course revision in the computer part. So find the time. Let's see. Hold up. Before doing part B, I didn't say that, I didn't calculate the time it took to reach the point 28.8. We have the final velocity, we have acceleration, and we have u. Can we find time? The easiest one is v equals at plus u. Okay, we know the final velocity once it reaches this point here is 0. Acceleration is negative 10. The time we don't know it. Plus the u is 24. So you get t equals 2.4 seconds. Okay, and in part A, my answer of 28.8 is wrong, because they want the maximum height. They didn't want how high, no, with respect to here. Here they're taking, and with respect to the ground, what's the height? We know this is 45. So, and then this is 28.8. They want the total, so just add 28.8 plus 45, and you get 65, 73.8. I think 73.8. Yeah, 73.8. Okay, so height is 73.8. Be careful, huh? Okay. Find the time when the pebble passes by the initial position where it was shot and determine its speed at that instant. So find the time where it reached over here again. So now we know going up it took 2.4 seconds. Okay, then going down, you're going down at the same acceleration. This is what you write. Same acceleration uh, and distance, right? Because it's the same 28 point meters. You're going up and you're going back down the same, using the same acceleration, 10 or negative 10, and the same distance. So that means same time. So time total is equal to 2.4 to go up and then 2.4 to go down, which is 4.8 seconds. And determine its speed at that instant. So let me erase a bit here. Now we know V equals, we know that acceleration is 10, right? We know V equals AT plus U. Or, before writing this down, we know in this case, when it's going back down, they want to find the speed. We know that the initial velocity in this leg of motion, forget about all the stuff I did over here, going down, the initial velocity is 0. We know that the acceleration is 10, and we know that the time to reach this point here is 2.4, right? Can we find V if you have A, T, and U? Yes, of course. So over here, very easy. You substitute the values. V is going to be equal to acceleration, which is 10, times 2.4, plus U, which is 0, which should get you 24 meters per second. Is that correct? I don't know, it feels wrong. Ah. Why though? Why negative 24? Oh yeah, they want, negative 24 is, but why though? Why is they using negative as the acceleration? It should be positive if you're going down. Okay, let me see here. Come on, they use a different way to solve. Negative 10. How did they solve the first part? Now we used V squared minus U squared. What did they use? Yeah, okay, they use this. But why? Why? If it's funny, it shouldn't be negative. It's just here, part B, I'm not convinced, صراحة. Okay, they use the same way as us. So I don't understand what they did here. I don't know why they're doing this. كل هيدا على الفاضي. Okay. Oh, by the way, if you're solving free fall, the first thing you write is that A equals G equals whatever value they gave you. Okay? And I'm not convinced why A is negative 10 if you're falling down. It should be positive 10. This should be positive 10. I don't know in the solution why they made it negative. But okay, the speed we got the same answer. Since they ask for speed, just say 24 meters per second. Again, still not convinced. Because you can't have it negative for going up and a negative for going down. The solution I think is wrong in this. Please correct me if I'm wrong in the comments. Okay, what can you deduce? What can I deduce? Which it's the same. Yeah, it's the same as its initial speed. So yeah, we passed it here at 24 and we started at 24. So it's the same as the initial speed. What did they say? Alternatively, you can use V squared minus U squared equals, what's this 20? Minus 2A. Okay. Yeah, okay, that works, I guess. You get two values. Okay. Okay. Yeah, let's forget about this. Yeah, I guess there's nothing any. My solving is correct. So I don't get what they said here. What can you deduce? What can I deduce? T equals 0 is the instant. I think what they meant by what can you deduce is that it's the same as the initial speed. I want to see what did they say. T equals 0 is the instant the pebble is launched, and T equals 4.8 is the instant passes again by that point. Therefore, the total time from the time the pebble is shot to the time it reaches the initial position again is 4.8. Note that this is twice the time the pebble takes to reach the highest position. A point to remember. However, it cannot be used in a free response question without derivation. Okay, forget about this. That's a lot, yeah, bro. Okay, part C. Find the instance when the pebble is 10 meters above the shooting point, and then 10 meters below it. Okay, أكيد when it's 10 meters above the shooting point يعني x equals 10, right? ونحن what do we have? We have the acceleration, right? Which is so I wrote it somewhere, right? A equals g equals, since it's free fall, when you're going up, a equals g equals negative 10 meter per second squared. Okay, use this note. Okay, uh, by the way, since we're using free fall, you can't use x equal. You know, when you're writing the formulas, make sure to replace x with y, okay, and a with g. Okay, you're supposed to do this when you're solving free fall. Okay. Anyway, let me solve here. We want x to be 10, okay, and we want to find the time. We want t. We have x. We have the acceleration, okay, and we have the initial velocity, which was 24, right, when it was thrown. So let's see. 10 equals half acceleration, which is negative 10 t squared. We don't know, right? Plus ut, we know it's 24 t plus x naught is 0. We don't care. So you're gonna get minus 5t squared plus 24t. Take this here. Plus 10 equals 0. Calculator. Let's see. Equation mode. 3 minus 5, 24, 10. You get 5 point. Let's make it 3 significant figures. 5.19 seconds. T1 equals 5.19 seconds. T2 is also positive by. Oh, what did I do wrong? Ah, minus 10. I took the 10 here. It should be minus 10. Minus 10 equals 0. Sorry. هيدي minus. Okay, you get 4.33. Yeah, this I think this is correct. T1 is 4.33. At 4.34, whatever. T2 equals 0.461. So you can say, Walid, how do you have two solutions? Look, 10 meters above is over here. You're at two instances, here and here. You get what I mean? So you get 2 times. And then below it, we just replace it with minus 10. It's here on minus 10 equals half. Again, and I'm convinced it should be positive t. Let me see if you get the same answer. 24. Again, the initial. Oh no, the initial was. Hold up. لا, here it's still gonna be minus 10 as your هيدا, because we're still talking about the origin being here. So the motion that goes like this. Okay, the origin is still here. It's with respect to here. So your acceleration, yani we started here, it went like this. So we're still referring to g as minus 10. Okay, so you're gonna get half. Okay, whatever, minus 5t squared plus 24t plus 10 equals 0. Again, calculator. Minus 524 on top 10. You get 5.18 and negative 0.3. So أكيد only one solution, which is here. So t equals 5, t1 equals 5.19 seconds, or t2 is minus 0.1 she, what was it? 0.385. This is rejected. So your only solution here is this. Okay. Okay, no, I just realized why here I was supposed to use negative 10 as the acceleration. Again, because نحن we're taking this whole motion, we're taking the origin as the point here. فأنت when you go up, it's gonna be negative 10. حتى if you're going down later, the first part of your motion, you're using it as negative 10. That's why in here, it should be negative 10, negative 24, and then they want speed, so absolute value of minus 24 is 24. For part D, find the speed as it hits the ground and calculate the time it takes to get there. Now we have the height 73.8 meters. Okay, we have u, which is 0 in this like leg here. We also know uh acceleration, this is u, we know acceleration is -10, and we want v. Okay, how can you find v having a, u, and h without time? How can you find v without time? We use the equation v squared minus u squared equals 2ax. U is 0 because you're starting from here, from rest. Okay, equals 2 times acceleration -10 x, and you're gonna get v squared. Hold up. Okay, I just realized. Okay, if you wanna use u as 0, let me erase this. كل هيدا it's pissing me off. If you want to use u as 0, like I did here, that means you're taking this one here as the origin, right? But نحن we know that we're not taking this as the origin. We're taking this point as the origin, and at this origin, u is 24. So we have to go back here, and we're gonna change our equation a bit. Okay, I just realized I was solving it a bit wrong. We want v, given that at the origin, you always look at your origin. نحن we took origin here. u is 24. g is -10. وكمان the height x or h from this point is -45 meters, because the height of the building is 45. So to finish, it's -45, right? Use v squared minus u squared equals 2ax. You're gonna get the same answer, by the way, but you'll see. V squared we wanted minus u squared minus 24 squared equals 2 times -10 times -45. So you're gonna get, take it all to the other side. It's -20 times -45 divided by, ya Allah, did I do something wrong? Negative, no, I did something wrong. -20 is positive. So you're gonna get 900, yeah. So v squared, okay, minus 24 squared equals 900. Okay, minus 24 minus 24 squared, ya Allah, minus 24 squared, minus 24 to the power of 2 minus 576. So v squared minus 576 equals 900. Then you do 900, take it to the other side, becomes plus 576, right? So 900 plus 576. Okay, so you're gonna get 1476. So v squared equals 1476. So v equals, remember, plus minus root 1476. Okay, root answer, you get 38.4. So v equals plus minus 38.4. Okay, let's see. نحن do we want it positive or do we want it negative? نحن we want it negative. We took this one here, this motion, as increasing. We're taking this as our origin. So we're going up. Now we're going down. We're falling down. So akid we're going to take negative 38.4 meter per second. Find the time it takes to get there. You can just do v equals at plus u. Okay, the velocity negative 38.4. Okay, equals the acceleration negative 10. Remember, with respect to the origin, huh? Negative 10 times the t plus 24, which is our u. You solve this, you get minus 38.4. Take the 24 to the other side, becomes minus 24. Okay, then divide by negative 10. You get, oh shit, how much is it? 6.24. 6.24 seconds. هيك خلصنا. Thank you so much for watching. Good luck. Wait, no, let me see the top question. I'll do this top question because صراحة شكل it looks like a question that could come. The variation, maybe in the written, even though he did say past papers will come in the written, I'll still solve it. This region, wallah, he's unpredictable. The variation of the position of two carts with the same time is shown below. Initially, the first cart moved with speed u, so cart 1 has this speed u, v equals u. Okay, and the second cart starts from rest. So for second cart, u equals 0. Or let's say, I'm going to call it v0 because here we used u as something else. Determine the initial distance between the carts. Okay, I think a 12-year-old can do this. 6 minus 2, 4 meter. Determine the value of u. Cart 1, can you find the average velocity? We want us to find the average velocity. It's a straight line, you just find the slope. Let's take this point, 0 seconds, 2 meters, and here, 1 second, 3 meters. Find my essential, 1 over 1 equals 1 meter per second. Okay, indicate the instant that the carts pass each other. When do the carts pass each other? 2 seconds. And that's, I don't know what to tell you guys. So easy, wallah. The second cart moves with a constant acceleration. Calculate its value. Okay. So they told us it moves with a constant acceleration, meaning it cart 2 moves at UARM. Now we're comparing x's, right? For cart 1, since it's moving with a constant velocity, x equals vt plus x naught. This is for cart 1. How about for cart 2? It's UARM. We have the time. We have that they told us that v initial is equal to 0. It was in the question. I'm not going to go back up because I'm going to lose the writing. Okay, we have the time. It's 2 seconds, right? We're saying like when the cars meet, right? Also, yeah, we have a, we have t, and we have x, we have t, we have u. We want a. We know that x equals half a t squared plus v naught t. I'm going to replace u with v naught plus x naught, right? Now we know that when the cars pass each other at t equals 2, x1 equals x2, right? Because they're passing each other. So vt plus x naught, for the first car, we found that the velocity was 1 meter per second. So 1t plus x naught, its initial was 2, equals half the acceleration. We're trying to find it, right? Times the t squared. Hello, we'll substitute in a sec. Plus v naught t. V naught was 0, so this is 0. Plus x naught, which is 6. We know that t equals 2 seconds. So 1 times 2 is 2. Plus 2 equals half a times 2 squared, which is 4. Plus 6. Let's do this. 4 equals half times 4 is 2a. Plus 6. You get 2a equals minus 2. A equals 6 minus 4. Hold up. Yeah, you get a equals minus 1 meter per second squared. For part E, when they say calculate the speed of the cart as it passes the origin. Origin is when x equals 0. Okay, we know that x initial is 6 meters. So to go from x 6 to 0, we have to go minus 6. So that means my x is minus 6, right? Now we have delta x. So they basically gave us delta x. They want speed, so they want v. Now we have a. So we want to find the velocity without time. Remember, and how I memorized this equation, v squared minus u squared equals 2a delta x. I memorized because I think of it whenever I don't have time. We call this the time independent, okay? So we know u squared is 0 because it was in the question. V squared equals 2 times acceleration negative 1 times delta x negative 6. So you're going to get v squared equals 12. So v equals plus minus radical 12. Is this how they solved it? Oh, they kept it positive? Okay. So why is it positive? It should be plus minus. Yeah, I think it should be plus minus. Okay, anyway, so you're gonna get whatever. How much is it? They just kept it 3.2 times. Is radical 12 3.5? No, it's not 3.5, so 3.46. Okay, yeah. So they kept it as plus minus 3.46 meter per second. They rounded it to 3.5. So plus minus 3.5 meter per second. هيك بنكون خلصنا. Thank you so much for watching. Good luck on Monday.